Let's write some more combustion reactions. All right. Glucose is C6H12O6. Learned that in biology. That's a solid. And we're going to burn that in the presence of oxygen gas. This is kind of what happens in cellular respiration. You get water and carbon dioxide. All right, so a lot of these, and on your test, they're all going to be complete combustions. So it's pretty straightforward. Just plug in the fuel and the oxygen in the reactants, and then the water and the carbon dioxide in the products. And if you run into any difficulty, it's likely going to be in the balancing part. All right, so carbon, hydrogen, and oxygen appears in two different locations, so two different lines for them. 6 carbons and 12 hydrogens, and 6 from the glucose, and 12 oxygens from the wait, what? Nah, it's too early to make mistakes. Okay, it's too many places to make mistakes. All right, it's 6, 12, 6, 2. Okay, I'm going to write in the same order on the product side, and happens to be oxygen appears twice, two different locations there as well. All right, fine. 1 oxygen from the water and 2 from the carbon dioxide. Now, because oxygen appears in two different locations on multiple places on both sides, I'm going to do that last. All right, I'm going to do the hydrogen first because that's where my odd oxygen is connected to. And so I just want to make sure it's going to turn even, because the left side is only, I can have multiples of 2. All right, so I'm going to do the hydrogen first. 2 times 6 is going to give us 12 hydrogens on both sides. That 6 needs to go where I see the H, and also update that oxygen. And yes, it's all even. Gonna be even. All right, now we can move on to the carbon. So times 6, 6 carbons on both sides. Let's put that 6 there, and then also distribute that 6 to the oxygen on carbon dioxide, and you got 12. All right, 12 times 6 is, 12 plus 6 is 18. All right, now we just got to manipulate this lone oxygen to get 18 total. So we have, so another way you can do this is 18. It's got to add up to 18 minus the 6 from there. So we need this part to be 12. And then that'll equal, I'll probably just confuse you. All right, anyway, I need 18 total. 6 of it's feeding in from there. So 12 must come from that one. So that's what I'm trying to say. All right, so let's multiply this by 6 to give us 12, right? So 12 plus the 6 will give us 18. All right, we need the 6 there. All right, 1666 looks like our answer. And B, acetone, liquid. All right, C3H6O1, and we're told that that's a liquid. We're going to burn that. Oxygen gas, arrow, water, steam, and carbon dioxide. Getting the hang of this? All right, balance. Carbon, hydrogen, oxygen appears twice. 3, 6, 1 oxygen from the acetone, and 2 from the oxygen gas. Same order. Oxygen also appears twice on the product side, and it's going to be 1, 2, 1, 2. Need to hang of that. All right, so ooh, now this one, get a different shade here. This one on the left side is an odd number. This is the one I'm going to manipulate last. And on the right side is an odd number. All right, let's just see how this plays out. Let's do the hydrogen first. All right, 2 times 3 is going to be 6. So let's put that 3, get 6 hydrogens on both sides, right? Update that oxygen with also 3 and right, let's see. Well, look at this. Oh, hold on, it might be good. Let's just keep going. Yeah, let's just keep going. All right, so carbon, we're going to need 3 there to get 3 on both sides. All right, let's multiply the oxygen attached to the carbon dioxide also by 3, and we got 6. All right, we got 9. All right, we're looking good. This is fine. All right, so we need 9 total oxygens on the reactant side, and we don't want to touch this one. That's connected to all this other stuff, and we just balance all that other stuff, so we don't want to touch that. All right, so 9 minus that 1, we need to get this thing to be 8. All right, and we can do that. Just multiply it by 4. All right, so 8 plus the 1 is going to give us 9. All right, so that 4 needs to go in the coefficient where you see that oxygen is going to be right there. So it's 1, 4, 3, 3. Okay, not bad. I have a feeling you're going to throw us a little hairy one on this last one. It's been too easy. All right, yeah, pentanol. Pent means 5. 5 carbons in this alcohol. All right. 5, let's say 12. Liquid. Yep. All right. All right. So they're giving us that, and we just plug in the rest. Oxygen gas, H2O, and carbon dioxide. Complete combustion. All right. Yeah, I got a feeling it's easy, medium, and hard. That seems to be the trend. Okay, let's carbon 5 on the reactant side. Hydrogen is going to be 12. Oxygen from the pentanol is 1 oxygen, and from the oxygen gas 2. All right, in that same order. 1, 2, 1, 2. Okay. Alrighty. We'll do the hydrogen first. Times 6 is going to give us 12 hydrogens on both sides. Oops. Let's put that 6 right there in the coefficient where you see H. All right, let's update that, and that's going to be 6. Yeah, see that? So this is this is an odd number. I'm sorry, that's an even number. But the left side is this odd number. We need to change to an even, and when that thing is connected to all of that. So we're gonna. I'm gonna start with a 2 here, because I want to start with I want to evenize the reactant side. I hope you're seeing that. If not, you can go through it and you'll see that we'll need multiple pentanols. All right, so I don't know where my eraser is. Just gonna scribble that out. So it's gonna be 10. We're starting with 10 and 22, 24 hydrogens and 2. All right, so I did that so I can get an even number on the left side, because it looks like I'm going to get an even number on the right side. All right, so let's start with hydrogen again. 2 times 12 is going to be 24. Let's put that 12 right there. All right, now we need to update that. See that? Now we got even numbers. 12. All right, now let's do the carbons. We need to multiply this by 10. And 1 times 10 is 10. Also multiply that oxygen and carbon dioxide by 10, and we're going to get 20. All right, so everything looks good. So that's 32. So we're going to need multiply this by, well, both of these need to add up to 32. Okay, 2 of it's going to come there, so the remaining 30's got to come from the oxygen down here. All right, so 15 is going to give us 30. 30 plus 30 plus 2 is 32. All right. So one note: if you didn't see that, it's normal for you to start with carbon, and you'll just have to like go through it a couple times. It's completely normal. It just sometimes you gotta go back and forth a couple times. Alrighty, but you do enough of these, will kind of catch on to some shortcuts, but they're not all like gonna be like that. So just keep at it. There we go.